Okay, today we're going to talk about special triangles. But before that, we're going to but go over a couple of things about triangles. The first thing I want to talk about is first I want to talk about triangle inequalities. Triangle inequalities. And the question we're interested in is, can I just draw any triangle I want and say like this side is that, the second side is this, and the third side is another length. And so, for example, if I tell you that triangle ABC has sides 8, 11, 15, is this a possible triangle? Once again, you know I'm not the best drawer. I'm not the best artist. And I just drew this triangle without a ruler, and I should have used a ruler. And I just wrote 8, 11, 15. I can write whatever I want. But is this an actual real triangle? And the answer is yes. Are these possible sides? And the answer is, well, first of all, the sum of two sides of a triangle is always greater than the third. That's how you know you have a possible triangle. So for example, you could say, okay, 8 plus 11 is greater than 15, right? 19 is greater than 15. We know that 8 plus 15 is greater than 11. 23 is greater than 11. Where's the message? And we know that 11 plus 15 is greater than 8. Therefore, these are the possible sides of a triangle. I might give you another example. I might say, just write some triangle on the board and say, 1, 8, 11. Are these the possible sides of a triangle? And you would say, well, you can go through all the combinations, but the second that you immediately recognize that 1 plus 8 is not greater than 11, therefore this is not possible. As I said before, I can draw anything I want, but is this a possible or real triangle I can actually construct? The answer is no. 1. 2, other things. So the question is, how do we know? So let's take a look at Pythagorean theorem again. So let's take a triangle. We had an A, a B, and a C. Okay. I didn't put the right angle in. So let's say you discover that A squared plus B squared equals C squared. Well, that means the angle opposite the side, let's call this theta. That means theta is equal to 90 degrees. Once again, you're going to take two sides and look at a third. And once again, I've used the word opposite. This angle is opposite side C. We're going to talk about that a little bit more. But what if we don't have a right triangle? Can we tell something about this angle with other relationships? So for example, let's say it's not a right triangle, but A squared plus B squared is greater than C squared. Well, it turns out if A squared plus B squared is greater than C squared, then the angle opposite C is acute. And you can kind of envision that, like it's kind of like C is getting smaller, that means A and B is like shrinking. If C is getting smaller, the angle between A and B is getting smaller or less than 90. Now, what happens if you in those exercises that you had your A, B, and C, and A squared plus B squared turned out to be less than C squared? Well, it turns out that theta is actually obtuse. Once again, these might show up, it might not, but interesting thing to know. Other thing, let's move on. Other thing about the triangle, I've used this word, I've used the word opposite, and yeah, so the idea is, let's talk about the word opposite. We're going to need this. Opposite. Angles and sides are opposite each other in a triangle. So if we look at this triangle, let's take a look at this triangle. A, B, C. It could be any triangle. I don't know why I keep I guess it's natural to kind of just gravitate toward an equilateral triangle, but so let's talk about this. What is the relationship between angle C and the opposite? Well, we say that angle C is opposite segment AB. And we could also say that AB segment is opposite angle C. So I want you to think about what sides and angles are opposite each other. Okay, well, let's see. Angle B is opposite, and I'm getting lazy, so I'm abbreviating. Is opposite. What is angle B? Opposite side AC, and AC is opposite angle B. And then what's the last combination? Well, let's take a look at angle A. Angle A is opposite BC, and BC is opposite angle A. Now, this is kind of cool. The last thing I want to talk about before we start talking about sexual triangles, the last relationship I want to talk about, let's say that there's a relationship between the sides and the angle. It turns out if angle A is less than, let's see, the measurement is less than the measurement of angle B, is less than the measurement of angle C, that means that, this is kind of cool. So if A is the smallest side, if angle A is the smallest angle, BC is the smallest side. If angle B is the middle angle, AC is the middle side. And if angle C is the largest angle, AB is the largest side. And that makes sense. So in a right triangle, the side opposite the largest angle, which is the right angle, is the hypotenuse. And that's the relationship. So that's how you can tell if you know the angles, what's the largest side or the smallest side. You know in an equilateral triangle, all the sides are equal because all the angles are equal. Okay, good. Now, let's move on to special triangles. It's a quick little lesson. This is where the homework is going to be made mostly. What we're going to be looking at are special triangles. And they're special because you can actually construct them with a pencil and a compass. And so the two we're going to look at is something called a 45, 45-90 triangle and a 30, 60, 90 triangle. Okay. Let's start with the 45, 45, 90 first. Well, you might say, okay, well, if it's a right triangle, and we just learned that because the angles are congruent, the sides opposite them are congruent. Okay, so let's call this x and x. Now, I don't know what the hypotenuse is, so let's call that h. Okay, well, we know that we have a right triangle, so we're going to do this first. So I don't know what x and h are. I have all these variables in there. That's fine. I can still put this together in a formula. Pythagoras theorem. X squared plus x squared equals h squared. Right? 2x squared equals h squared. How do I get h alone? Well, how do I undo a square? Take the square root. Now, you might say, Mr. Adler, isn't it supposed to be plus or minus? It's supposed to be plus or minus, but because we're dealing in, we're just going to take the positives. So just take the positive. So we have h over here, we have radical 2 radical x squared, right? Because we recall from our radical lesson. Final answer, the hypotenuse is x radical 2. That's kind of interesting. So, just the quick lesson is, if you have a 45, 45, 90 triangle, the hypotenuse is radical 2 times the leg. Or the leg is equal to the hypotenuse divided by radical 2. That's the relationship. It's an important relationship. We'll be needing it for more advanced, trigonometry. Question. Find the diagonal of a square whose perimeter is 16. Find the diagonal of a square whose perimeter, is 16. Find the length of the diagonal find the length of the diagonal of a square whose perimeter is 16. I'm going to leave off the units. 16 centimeters. Okay, so you draw a diagram. It's a square. You know that all the angles are congruent. You know that all the sides are congruent. I'm going to draw a diagonal in here. You say, I have a right triangle. 2 of the sides are congruent. That means it's a 45, 45, 90 triangle. I know that a perimeter, so if this is, it's called S and S, I know that 4S equals 16, so one side is 4, and I just learned that to go from the leg to the hypotenuse, multiply by radical 2. Therefore, the diagonal is 4 radical 2. Once again, we have a square. When we drew in a diagonal, we created a right triangle. That diagonal is also a hypotenuse. We know that the perimeter is 16. All the sides are 4, 4, 4, 4 radical 2. Find the diagonal of a square. I have that. Find the perimeter of a square whose diagonal is 7 radical 2. Actually, let me change it. In a square whose diagonal measures 7 radical 2, find the area of the square. Okay, well, you have 2 methods. I want you to think about it. Okay, we're back. So I have a square, and I have the diagonal of 7 radical 2, and you say, you know what? These sides are congruent. I have a 45, 45, 90 triangle. I know how to go from my diagonal or my hypotenuse back to the leg, just divide by 2. So 7 radical 2 divided by radical 2, the radical 2's go out, 7 by 7. I was going to ask you the perimeter. We know that the perimeter is 28, but I asked for the area. The area is 49. Just an interesting trick. It turns out that the area of a rhombus or a rectangle, or a parallelogram is the product of the diagonals. This is a little advanced. What's the product of the diagonals? Well, 7 radical 2 times 7 radical 2 divided by half. So it's 1/2 the product of the diagonals. This equals 49. That's outside the scope of this class. Last thing we want to talk about. The next structural triangle is the 30, 60, 90 triangle. we just want to know, once you have a 30, 60, 90 triangle, what is the relationship between the sides and the angles? So let's see. So the question is, how are we doing for time? Good. The question is, how do I get a 30, 60, 90 triangle? Like, how do I make it? What am I going to do? Well, I can't, make equal sides, or I'm not really sure how to make a 30-degree angle, but what I can do is I can start with an equilateral triangle. So start with an equilateral triangle. Okay. Now, and so I'm going to say, because it's equilateral, all the sides are congruent. All the sides are congruent. I'm going to call all of these sides 2s. Or 2x. Okay, right? Now, last year, you should have learned that an altitude is perpendicular to the base. Let's see, we have, where's my ruler? This is an altitude. It does two things. It's perpendicular to the base, or it starts at an angle and it's perpendicular to the opposite side. It's perpendicular to the base. What else do you think that altitude in an equilateral triangle does to the base? It bisects it. Now, this is kind of cool. If the whole segment was 2x, each of these was x. Okay? Now, and then the third thing it does, and I forgot to mention this, so let's back up a little bit. So, I said it was an equilateral triangle, all the sides are congruent, and all the angles are congruent. That means this is 60, 60, 60. So, the altitude, it's perpendicular to the base, it bisects the base, and it bisects this angle up here, which means that this is 30, and we have our 30, 60, 90 triangle. Okay. Now, we know that because the order of the angles dictates the order of the side length, we know that the side opposite 30, this is the smallest side, this is the middle, and this is the largest. So the first thing we notice is that in a 30, 60, 90 triangle, to go from the small side to the hypotenuse, multiply by 2. So small leg times 2 equals the hypotenuse. It's kind of cool. What's this side though? How do we go from the small leg to the altitude, or the altitude to the hypotenuse? Well, we have a right triangle. So how do we relate the altitude to the other two sides? Well, let's call it h. Let's call this h for height, right? So in this case, and I know I used the h in a different case, shouldn't have. In this case, the h represents the height, x represents the small leg, and 2x is going to represent the hypotenuse. Well, once again, Pythagoras theorem. Let's see. H squared plus x squared equals 2x squared, right? Pythagoras theorem. It's h squared plus x squared equals 2x squared. Well, let's see. We have h squared plus x squared equals, remember, 4x squared. H squared equals 3x squared. This is kind of cool. H equals x radical 3. To go from the height, the middle. So to go from the short leg to the large leg, Excellent. So we can conclude take the small leg, multiply it by radical 3, and you get the big leg. And then we're not going to, we can come up with a formula for going to the medium, middle, to the largest leg. Personally, just get back to the smallest leg. So for example, sorry, this board's getting dirty and I have to clean it. So, sorry. So let's see. Nice. Good. We have these two rules. Let's take a look at one or two examples. So let's take a right triangle. And we have 5. We have a 90-degree angle up here. We know the angle, it's 60 over here, 30 over here, which means we know that 5 is the shortest side. And can you see the board? Yeah, we're good. And then let's see. I want you to find S and F. And so problems like these are really easy. You say, okay, well, to get from the shorter to the hypotenuse, that's F. And to get from the shorter leg to the bigger leg, you just multiply by radical 3. That's it. And you obviously you can work backwards. I'm not going to push that. Well, let's try another one. Let's say another one like this. This is 60. This is 30. Let's say, I'll make it a little bit easier. Let's say that this is 7 radical 3. The question is, what are the lengths of defined? Let's see, S, F, how about T and G? What do you think? How do I go backwards? Once again, it's a little advanced. To go from the short leg to the big leg, we multiply by radical 3. So to go from the big leg to the short leg, we divide by radical 3. Well, this knocks out. So T equals 7. And how do we go from the short to the hypotenuse? 7 times 2, 14. So it's 7 radical 3, 14. Question, find the area of an equilateral triangle whose perimeter is 24. Find the area of an equilateral triangle whose perimeter is 24. And then I want you to generalize, find the area of an equilateral triangle whose side is S. Now at this point you can shut the video off, or you can, I'm just going to do it on the board. So if the perimeter is 24, that means all the sides are 8. If I drop an altitude, that means the base is now breaking 4 and 4, and that means the height is 4 radical 3. So now I can find the area of the triangle. 1/2 the base times height. Final answer, 16 radical 3. Let unit, and then this is unit squared. What's going on here with the area of an equilateral triangle of any side? This is kind of cool. Well, we know that this is S, right? If we drop the altitude, we have S over 2, and that means the height is S radical 3 over 2, and now we can find the area. The area is equal to 1/2 the base times S radical 3 over 2. Final answer, this is kind of cool. Now you can find the area of an equilateral triangle. It's S squared radical 3 over 4. Am I asking this on a test? No. Should you know it? Can't hurt.